This is Shabir Rangwala. I head up patients consulting, and we do a lot of work in the area of autonomous driving and sensing for movement automation. And we're in a really great panel here. We are talking about the need for level 4 and level 5 autonomous vehicles. And I have a great panel with me, panel members with me, Alon, Michael, and Shahar, who will introduce themselves shortly. Alon, why don't you take it from here and give us a background of your company and yourself?
Thanks. My name is Alon Parhurst. I'm CEO of DriveU Auto. DriveU developed and is deploying an open software-based connectivity platform for autonomous vehicles teleoperations. I'll quickly explain. Autonomous driving, as we'll discuss in a moment, has come a long way, but still there are circumstances and scenarios in which an autonomous vehicle is expected to tackle difficulty, be it because of sensor failure or a lower level of confidence in terms of what to do next. In these instances, it will turn to a human in the loop, a remote operator, who will need to make decisions, give guidance, or even drive the vehicle remotely. In order for this to happen, the remote operator needs to see the world through the eyes of the vehicle, the camera, or the cameras. And in order for a remote operator to do her job properly, she needs to have reliable, continuous, and low latency connectivity. And that's exactly what we do at DriveU. We've built a software-based platform that fuses together using cellular bonding, multiple cellular networks. We dynamically encode video, and we enable best in the market connectivity specifically for AV teleoperations. We're an Israel-based startup, 18 people, with the systems live on 5 continents. Thanks.
My name is Michael Schön. I work at the Volvo Cars R&D Innovation Department in Sweden with advanced engineering activities. And prior to this, I worked as a product manager with the development of Volvo Cars' next generation high-performance autonomous drive car computer in collaboration with NVIDIA. So I'm an aerospace engineer and have worked for 20 years within the space industry, 15 years at the International Governmental European Space Agency, the ESA-ESTEC, near The Hague in Netherlands, with development of Earth observation satellites, scientific satellites, the Mars rover, etc., in collaboration with other space agencies and space industry. I'm trying to get in the space experience into the automotive domain so we can reach the same level of reliability.
Hey, Michael, quick question. Do you think going to space is going to be more difficult than an autonomous car? We'll talk about that. Okay. Hey, Shahar, go for it.
Hi, hello, everybody. My name is Shahar Ben-Nun. I'm the CEO of Tactile Mobility. Tactile Mobility is adding the sense of touch into mobility. We know when we all drive that we don't make decisions only based on what we see. No doubt that seeing, vision is the most important sense that we use to make decisions, but we all feel the car. We all feel the car, and then we make decisions based on what we also feel. If, for example, we feel that the road status is not good enough, we may slow down. If we know that it's slippery, we will slow down. We make decision by also feeling. And just imagine of making a decision based only on vision. When you remotely drive a car, imagine that your dear family is in a car in the darkness while it's raining and you're sitting miles away and driving the car. I think it's very related to this discussion with Alon. It's pretty much scary to make decision and accelerate to 150 kilometers an hour while it's raining at night, only based on vision. So we are adding the sense of touch. We are teaching the car to feel what we feel and making a much safer decision. We are doing that both in the ECU of the car, in the car itself, uploading those insights to the cloud, and also creating the surface and the combination of the surface and the car itself allows us to make smarter decisions.
Shahar, does that include acoustics as well? When you say feel, you're talking about sound as well, or?
No, we are not dealing now with acoustics yet. It's mostly about grip, for example, grip estimation, understanding the grip status both in the surface level and in the car itself.
All right. Thank you. Yeah, no, so I think, like I said earlier, I think this is a very important topic, probably as important as going into space, I think, which is why Elon Musk, I guess, is doing both. But let's dive into it, right? So I think Alon reminded me actually when we first started this conversation. The whole aspect of deploying AV, that's the tool, right? And these are really, I'm sort of paraphrasing what Alon said, right? Is what's involved is there a business? Is there money to be made, right? So that's important. I mean, it's a very important thing, right? And so that's one. The second one is, what are the technology barriers, right, to kind of making this happen? And that includes a lot of things, right, which we will talk about. But then, of course, there's regulatory, and I would say there's maybe a fourth leg to the stool, which is sort of consumer acceptance, and maybe this goes a little bit into what Shahar was saying, right? Is are you going to be comfortable with your family being in a autonomous car in the middle of a snowstorm, right? So yeah, I think maybe there's a fourth leg to it, and so we'll see how far we get into some of these details. But maybe the first aspect to talk about is the business aspect, right? So the L4 autonomous vehicles, just for the audience, is obviously something where the car is handling itself without a driver in a prescribed operational design domain, right? And that can include weather, it can include geography, it can include roads. So it's a very prescribed sort of territory in which this is happening, right? And so then the question becomes, what are the business drivers for that? And so, of course, classically, people always talk about ride-hailing services like the Uber and the Lyft sort of model, right, as being a consumer of this kind of thing, right? But I'd like to kind of start off with this topic. What is the business aspect of L4? I don't want to talk too much about L5, and maybe we can later, but L5 I think is a little further away, but I'll ask the audience, I'll ask the panelists also to comment on that.
I'm okay to start on this, if that's okay. In terms of what we've seen in the industry, if you go back in time just a little bit, as early as 2016, if you would be around Silicon Valley, and people, I heard this from a VC, they were talking about not needing to renew your driver's license because soon we'll all be, hopping into AI-driven Ubers. So obviously that didn't happen exactly as described, and I think there's been a realization or a shift between thinking of the industry of L4 as a tectonic shift that will happen in a couple of years, following which ownership of a vehicle would be a thing of the past, to a bit more realistic understanding that this is a very hard undertaking and an aggregation of use cases. So ride-hailing is an important one, and in my own personal opinion, will be the largest one going forward, and there's been a lot of announcements around this very recently. But if you think of other narrowly defined use cases, such as autonomous trucks, or autonomous on the highway and something kind of in the middle from the warehouse to the ramp and then from the ramp to the warehouse. And this triggers or ticks a lot of boxes when you think about the business case because, for example, in the US today, there's a great shortage of truck drivers. And so the business case for autonomous trucking is upon us today. That's why you're seeing a lot of work and an inflow of capital into startups or companies building autonomous trucks. Another example of this acceleration is something that maybe is not perceived to be classic L4, but think of autonomous sidewalk delivery robots that saw a lot of acceleration following COVID. And so the business case there also is apparent, certainly in times of lockdown and maybe also afterwards. So I think when we talk about business cases, we should not speak of a single overarching business case that applies to all use cases of level 4, but rather this aggregation of specific use cases that will end up being this tectonic shift in which you'll see level 4 truly, ubiquitous all over all use cases you can envision. That's probably 10 years out, which also kind of feeds into the level 5 vision. But today and in the coming few years, what we're seeing in our interactions with partners and customers are these narrowly defined use cases that have a strong business sense.
Yeah, I can add a little bit on what you covered. You covered already quite a lot here. But what I think it boils down to is trust. AD is all about trust and safety. And this was also evident during the CES conference when this topic was discussed. Customers today, they understand two levels. Either you are responsible or the car is responsible. Of course, we are discussing now all these 5 levels here, but in the communication to the customer, we need to be very clear who is responsible. So, of course, AD, as you pointed out, has a lot of business opportunity. So North America is currently spearheading, but China is predicted to lead the autonomous vehicle in the future. And for example, the AD component market by 2030 is expected to be around $39.5 billion for China. And that is more than US and EU combined. And if we look on the 2030, the new car sales worldwide for AD level 2 would be around 38 millions. For AD level 3, around 50 millions, and level 4, 50 millions, and level 5, around 6 million. So that means that ADAS would still remain the most common AD level until 2030. So what's happening now, if you look on the outlook here, when it comes to the technological trend, it's clear we need better performance, or there will be better performance, higher spatial and temporal resolutions for the sensors, the vision sensors, radar, and also possible to look into other frequencies in the electromagnetic spectrum, in particular, for example, for nighttime or difficult lighting conditions. So both the business outlook is very promising, and we have a lot of enablers now in place to make this working.
No doubt that there will be a long hybrid period of ADAS cars as well as regular cars driving in together. A key solution to the ability to have a proper hybrid, not in a future world where maybe all the entire cars are autonomous, that would determine the speed of the implementations and of autonomous vehicles on one hand, and on the other hand, the technology that will enable both regular cars with a human factor in place and autonomous vehicles without a human factor in place. Once they are both balanced together with the help of technology, that will enable many more business cases that right now are looking completely futuristic.
So that's interesting. I think what I'm hearing is obviously L4 is far away still. I mean, it's not imminent, although you'd argue Waymo actually does have an L4 operation and in a certain section of Arizona, right? But I think in general what I'm hearing is L4 is primarily a business to business sort of thing, right? I mean, maybe it's trucking, maybe it's ride hailing. It's not like we're going to sell consumer cars, right, with L4 capability anytime soon anyway. Is that a fair assessment?
I think the first L4 cars will be developed or run in a kind of very controlled environment. You don't start with every kind of road, but what you do is you certify the kind of roads where you can really run them. And then as you learn, you can extend that road network.
Okay. No, and I read a really good report on on the Waymo situation, offering ride-hailing services in L4 cars in certain towns in Arizona. And really the discussion there was that they're not expanding it, not because of technology, but because the business aspects are just not useful enough. And it's
Yeah.
costing them a lot of money, actually. They're losing money, right?
Yeah.
And so I think trucking is certainly a big driver, right? But I wonder if trucking is big enough to sustain the investments that are going into sort of L4 kind of activity. But that's an open issue. But I think that's kind of where we are, right?
Well,
Yeah, but
just one, if I may, one clarification on the ride hailing. The description of the situation in Arizona is accurate. I don't know that the decision not to expand is driven because of a lack of a business case. It might be worthwhile to add that in China, Michael mentioned China as a power in this space. In China, in Shenzhen, AutoX is already offering level 4 robo-taxis in commercial use, and there are numerous additional launch dates expected across cities in China specifically for ride hailing. So yes, if the question is whether or not there's a positive ROI within a year or two on ride hailing, I'm pretty sure the answer is no. But I think the early deployments and the commercialization of robo-taxis in the States and in China and soon in Korea, Japan, and Europe as well, I think they're meant to serve another purpose. A is to gain public acceptance, and B, as odd as it might sound, to capture market share. Once you deploy in a city, you're actually expanding on a bridgehead that will make it difficult for competitors to come into that space as well. Again, all of this specifically on robo-taxis and the appeal of their business case. This is something that lives side by side with things like autonomous trucking, middle mile delivery. There's been some announcements around that. And lastly, delivery robots.
Correct. Okay.
Sorry, maybe I could just add that we've been talking a lot about the vehicle now, but the road infrastructure and the communication between the vehicle and the infrastructure is very important as well for the ADM business.
That's true, and we will talk to that. So maybe we should pivot a little bit into sort of the second leg of the stool, right? So let's assume we are going to make tons of money. Now the issue is, what are the technology sort of gaps, right? And maybe we can start off, discussing sort of the first. Again, this is by no way kind of prioritizing, but the AI, we hear a lot about machine learning and edge cases and the AI algorithms that go both into sort of the perception engine, of making sense of what the sensors are telling you, but also in the whole policy of how you control the car, right? And again, you've got to do this in fairly short time frames. I mean, because accidents could happen otherwise, and safety is the key. And of course, one big driver for AVs is it does have to demonstrate safety levels that I think exceed an average human driver's, right? I think that's what's going to be demanded of regulatory bodies as well as consumers, actually. So let's talk a little bit about the AI first, and do we think what do we think more breakthroughs need to occur on the AI and the computing, or do we think that's there and now it's simply a matter of generating more hours in different geographies and weather and all of that? I think that's probably a good point of discussion at this point.
Right. If I may take it, first of all, we're definitely not there. I think the feeling comfortable of driving of only 70 kilometers an hour outside the city with the current technologies and with current ability to process in real time the data that we're getting from the existing sensors is simply not good enough to increase to 120 kilometers. Nobody would want to use a car that is driving between Munich and Hamburg in 70 kilometers an hour. So, and right now these, so not only speed, safety, if things are changed on the surface itself, no doubt that these technologies, the AI technologies that are accumulating the data from the sensors in real time while driving and making the decision in real time in a sub-second need to be improved. We've seen the recent accidents that have happened and continue on delaying the deployment of autonomous vehicles. However, the technology themselves, the essence of the technology is already developed. It just needs to be matured. One of the things that Michael mentioned before is the relationship between the car and the surface. It's not only about the car itself driving, but understanding the relationship between the car and the surface. And each car is different. One car has, for example, just good tire conditions, and the other one doesn't have a good tire condition. The same car, the same road, the same weather, different type of speed would be requirement just based on the status of the tires. This is just a small example that the car needs to understand in real time what is the current status of the tires in order for me to take that curve in 80 kilometers an hour and not at 70 kilometers an hour. Every average driver that you mentioned, Sabir, knows that. He knows, and he doesn't even know why he knows that. He knows that this curve should be taken by 70 kilometers an hour just because of the status of his car, the weather, and he, and even, you know something, my son is an average driver, a beginner, he knows that as well. The machines simply do not know that. So the technologies are there, but they are not matured enough to have all the combination of the sensors accumulated, processed in real time, and make the right decisions.
All right. So that's interesting. I think if I hear you correct, Shab, I think what you're saying is there's no fundamental machine learning AI thing that has to happen. It's a matter of just gaining more experience and training your brain, the artificial brain, I'll call it, on sort of these edge cases of developing the intuition of understanding the car, understanding the environment, understanding other drivers around you. But do we think this can, because, you know, people have done calculations of how many hours of actual road experience you would need to replicate edge cases, right? And there are some who believe that simulations are the way to go. I mean, you do need to have real world data, but then supplement it with simulations. Do we think that's a reasonable path to kind of close the gap? Because, I mean, other than Tesla, I don't know anybody who has a massive quantity of cars out there, you know, feeding their networks, right?
Right.
Yeah, maybe I can comment on this. So what we will see when we talk about sensor, we need to see it as an ecosystem. So we have the sensors, and all the sensors are connected to compute, and then we have the software stack in various layers on top of that. So we have a big shift now within the automotive industry. So the OEMs, they're taking much more responsibility on the top level now in the software stack, work that was previously done by the tier 1 or tier 2s. What we will also be seeing now with the sensor technology outlook is higher spatial and temporal resolution. We will see more sensors. We will see radar, for example, being developed with high resolutions. So LiDAR and radar, they will become somewhat more similar. The radar is, of course, more weather resistant. So the trend here is, of course, that the cost for sensors will go down. We will see also the connectivity with 5G and V2X in the car will make it better. So we have a lot of data. What you don't need, sometimes less is more. What you need is good quality data that you can really act upon. And of course, coming now to the AI part here, you train AI. There are two main ways to do it. One is to use replay data or pre-recorded data of millions of kilometers, and then just train it. And the second way to do it is to use synthetic data, and that is how you can, for example, create a digital twin of an entire city, and then you can do photorealistic rendering, and then you can inject any kind of error injection to see that the AI can handle that, because AI is only as good as it has been trained to. So if you have a very, very rare event, I mean, AI will only be able to say, okay, this is this object with a certain confidence. And if it has not been trained for another object, for example, it will not detect that. So, and then also all the vehicles, they will be connected. So of course they will detect this kind of, when something event is occurring, and then of course the network will be able, with this cumulative data, also be able to improve the AI algorithms, and then you can auto up new incremental improvements also of the AI.
I'd like to just hop in on a small kind of maybe fine tuning, if you will. So you've asked about the combination between simulation and real world driving. In a previous company that I worked for and is presenting at Ecomotion as well, Cognata, have made a lot of work in that space of simulation. And the answer is that it is a combination of lots of miles on the real world, but you cannot simulate for everything in the real world. And so you need to close those gaps via synthetic simulation and a combination thereof. But I would say something that I don't think is overly provocative. I think at the end of the day, autonomous vehicles will be out on the road without having faced and successfully overcome all possible scenarios. To think otherwise would be a mathematical impossibility. And so what we will be seeing are initial deployments in well-defined environments, maybe well-defined weather scenarios. I'm sure all of us have seen hours and hours, well, maybe we haven't seen it through, but hours and hours of robotaxis from Mobileye and others that are on the web, and you can see uninterrupted driving, granted in pretty good weather, but in pretty harsh traffic conditions, such as Jerusalem, which is pretty hostile in terms of traffic. And I think it's a question of management of expectations. There will be situations in which an autonomous vehicle will not know with sufficient confidence what to do next, and that's okay, because the AI stack will have a minimal risk maneuver, which is a fancy word for saying, let's stop on the side and figure out what we're doing next. That's where, in many cases, teleoperations will kick in, but I don't want to steer the discussion towards that. We need to have a realistic expectation in terms of how good or how safe is safe enough. I would argue that some of the software stacks that are being driven in Arizona and in Shenzhen today are safer by far than an average human driver.
Yeah, good point. Yeah, no, I think, this simulation, it just struck me what Shar was saying. Let's say understanding your tire conditions or the condition of your car, right? This is something you could easily take a machine learning stack and perturb it, right? Synthetically. Because the physics of that are understood, right? And maybe you could train it for that. So yes, I think there are physics-based models that can be used to perturb machine learning stacks, right? To kind of make them more kind of resilient. But okay, let's, just in the interest of time, I think this was a great discussion, but we should talk a little bit about sensors now, right? So Michael, you mentioned, I mean, obviously it's a whole system of sensors and compute and decision making and all of that. But I just want to get down to the sensors themselves, right? So certainly cameras I think are pretty good. There's talk of using thermal cameras. There is, of course, LiDAR is out there. There's radar, and as you say, radar is actually not quickly, but there's a competing view from the radar guys that they can do imaging, which would be great because then it's sort of weather resilient, right? Which optical techniques generally are not, right? But where do we think innovation or breakthroughs need to occur on the sensor side? So radar, clearly, if you could get that, I think that'd be great. but you know.
Yeah, I can give a top-level view of it. What I think will happen is we will get higher accuracy of the sensors. So better dynamic contrast, better frame rate, but that will also render more data that has to be computed. What we will see also is, all this data, of course, needs to be of good quality, so you can act upon it. Because if you have a lot of data and there is some kind of, I wouldn't say overlap, but ambiguity within the data, that's not good. So you need good data. Of course, the sensors, they will be exposed for weather conditions, so rain, dirt, etc. So the sensors also needs to provide good data. So sensor cleaning technologies, I think, is also important, or good surface coating to keep the sensors clean, so they can provide a good data as well. Another trend, of course, is miniaturization of the sensors. They will become smaller and cheaper. Another trend as well is that the sensors will become, if I say, less intelligent. So the intelligence will move into a more central compute platform. That is also another trend. And the rationale is that because when you get the sensor data in one location, then you can do sensor fusion and AI on that data. Because if you do that compute outside at the sensor themselves, it becomes more expensive, and you also lose the capability to get synergy benefits.
But that's actually quite a balance, right? Some people are saying you need more edge computing, right, on these sensors, because otherwise 90% of the data it puts out is actually useless, right?
It depends. I mean, if your latency requirements is down to a few milliseconds, then of course it needs to be in the edge. If the latency is somewhat slower, then you can do it central compute.
So again, I want to drill into what do you think are the biggest gaps on sensors today, right? I mean, I understand about miniaturization and all, but those are engineering things that are there fundamental gaps? Like, so for example, is cameras, I believe, are pretty good, right? I mean, does anything more need to occur there? Does anything more need to occur on LiDAR, on radar? You know, where are the gaps? Is anything holding us back on the sensor side?
Well, you know, today when we were talking about sensors, we were talking about visual sensors. Visual sensors, yes, LiDARs, radars, cameras are all pixels. All pixels are huge amount of data. Huge amount of data need to be processed in real time. Some of the technologies that are required for autonomous vehicles resides in the cloud because they need to have the combination of also other vehicles, the status of the surface, weather, etc. So it's a lot of data to process. What we think is that in addition, part of the gaps that you're asking about is also the non-visual sensors that will provide completely different physical modeling, the same type of information, but completely different family of information that only the intersection of different physical modeling that will bring the same results, meaning the same decision, that will prevail. Okay, because of one type of family is simply not enough because they all have the same type. They will all fail in the same scenario. So you need to have two different families completely.
So modality,
making this, sorry?
Sensing modality matters, right?
I think right now this is only at the birth of those type, because yes, no doubt that sensors, as we say, the visual sensors are all advanced, resolution is pretty good, and the technology is pretty good and advanced, but this is simply just not enough to make all decisions. I agree with Alon that we don't need to know everything in every situation before we go out. Yes, it will be while deployment is already started. But I don't think we've met yet the minimum line.
Thanks, sir. So as usual, as what happens is we were worried we'll have too much time on our hands, but we are of course running short. So I just want to address a little bit maybe the last topic, which is sort of infrastructural needs. And here I include things like teleoperation. I include vehicle to vehicle or vehicle to infrastructure, mapping data. What else needs to occur to make L4 happen, right? And I know, so maybe Alon, you can talk a little bit about sort of the telecontrol kind of aspects or teleoperation.
Yeah, so thanks. I think everything you've mentioned in terms of infrastructure is important and is at some stage of being realized. Before COVID, I visited China a few times, and it seems like all infrastructure plays are more advanced, not surprisingly, than elsewhere in the world in terms of V2X and the deployment of 5G. Teleops is interesting because it serves that, let's call it good enough approach that I mentioned before. Because if you acknowledge the fact that today, and I dare say 20 years from now, you will still need some level of human supervision for instances that will happen, more and more rarely, right? Think of MTBF, mean time between faults, as it extends as the technology matures. But still you will need, or we will need, this capability to supervise and when needed intervene. And we have the infrastructure in place for this today. It's called cellular networks. The challenge there is that it needs to be more than one, and of course that's where we come in with cellular bonding. But taking this to a broader scope, I think having teleops or recognizing it as a means to accelerate the deployment of autonomous driving is critical, and thankfully is already accepted by most of the players in the industry. Acknowledging the fact that it's a step-by-step process, right? They started with having safety drivers in the vehicle itself, and then taking the safety driver outside of the vehicle, enabling them to step in when needed using teleops. And when we talk about large-scale commercial deployment, think about operation centers in which remote operators will be called upon by the vehicles themselves when intervention is needed. This is just one important example of acceleration of the deployment. I'll let my friends answer other aspects in terms of infrastructure.
Please, go ahead.
Maybe I can bring up 5G in this context as well. So 5G is interesting because it does not only give you a higher data rate, but it significantly improves the latency in the communication, and every millisecond counts for an AD vehicle. In addition, also the latest version of the 5G standard also supports location services, and also the vehicle-to-X communication or the vehicle-to-infrastructure communication. So all these four elements is very important. And touching upon location, I mean, there are two types of location. There is absolute location and there is relative location. So for example, GPS or multi-constellation GPS navigation will pinpoint you to an absolute location, but it will not give you the relative. And that's why you need the external sensors around the vehicle to give you the relative distance to your surroundings. So, but all of these are enablers. What you need to put on top of this endplane, that is the software logic.
Shahar,
one additional aspect of the infrastructure, of course, you mentioned it, Sabir, is the maps. I mean, accurate maps that simply do not exist today. Those maps that are required to allow autonomous vehicles to drive freely simply do not carry right now the information that the car needs. It's just not enough. I mean, yes, there are some maps that can allocate the location of the distresses and other things, but all the things that are required for a safe driving of an autonomous vehicle is simply not there. So the maturity of those maps, in our opinion, are critical for the success of the deployment.
Very good. I think this was a great panel. Thank you, everybody, and thanks to EcoMotion for organizing it. Michael, I am going to ask you this question again. Do you think this is going to be tougher than space or not?
The Mars rover, that is a kind of an autonomous drive.
Right. With steady operation, of course.
Exactly, yeah. And that's what we fly. So
Okay.
we will fix that.
Okay, all right. Okay, thank you very much, everybody. This has been a pleasure. And again, thank you, EcoMotion. And I hope everybody enjoys this. Thank you.
Thank you very
Bye-bye.
much. Thank you, Sabir.
Thank you very much. Bye-bye.
Bye.
Bye.